Okay. Do you have any other questions? No, now let's review. We have 4 principles. Principle number 1, any number times 1 stay the same. Number 2, any number add 0 stay the same. Okay, these 2 principles, okay, you can apply anywhere you want, because whenever you have a number, you multiply by 1, add 0, it's not going to change the number. So you can do that freely whenever you want. Number 3 and number 4, however, can only be used in situations where the if statement, the if condition is satisfied. Okay, so that's 1, 2, 3, 4 mathematical principles. We talk about there are 6 mathematical principles. So let's get to number 5. Principle number 5. What is principle number 5 in your notes? Go to the first page. Look for number 5. Look for number 5. Number 5 says. Okay, so I'm going to copy and paste number 5 here from the notes. It's a very important principle. I'm sure you have used it before, but if you have forgotten it, it's not a big deal. That's why we're here for. Okay, that's why you're here. We review these principles. If a product of 2 number is 0, if and only if one of them is 0. Okay, this property is called zero product property. Zero product property. This property alone explains to you why you had to learn how to do factoring. Okay, principle number 5 alone, of course, principle number 6 also. This is the principle to explain to you why we spend so much time on factoring. Do you guys still remember the years those times in your either middle school or high school or in your college years you had to do factoring? Did you enjoy those times? Did some of you like to do factoring?
I did.
It's a hate and love thing.
I know, it's a hate-love relationship, right? You like it sometimes, you hate it sometimes, and it's frustrating. And sometimes you may wonder why we do this. Did you ever have a moment you say, why do I have to do this?
Yeah.
Of course, you're entitled to ask that question. Principle number 5 and principle number 6 tells you why. Because if we get a factored form, okay, if we get a factored form, right? Suppose you get a factored form. The factored form could be something like this. And the factored form is 0. The product of 2 quantity is 0. In our past experience, for example, you might have reached this point, right? You might have A equals to X plus 1. You might have a B equals to X minus 3, right? These are the examples, right? These are the examples. When we get to this situation, you can use principle number 5, right? Because when the product of 2 number is 0, then one of the numbers must be 0. Does that make sense?
Yeah.
So elementary algebra, intermediate algebra, in those 2 courses, okay, you might have taken it 5 years ago, 10 years ago, 20 years ago, 2 years ago, 1 year ago, last semester. Why do you think we need to do that? It's because we want to use the zero product property. Okay, so what does this zero product property say? Well, On one side is easy. On the other side, it's also the same. If you have a number as a multiplier, then the product is going to be always 0, right? So no wonder that in your previous experience, you might have learned that if this is true, this is if statement. Remember, this is if statement. This is if statement. If this is true, then one of them is 0. Okay, so x plus 1, either x plus 1 is 0 or x minus 3 is 0. Do you remember these examples? Right? And then you get x equals to -1. Or, of course, you know the answer, x equals to 3. Okay, it's because of principle number 5. Okay, so let's go back to explain the meaning of principle number 5. Then you say, oh, I remember I learned that principle in elementary algebra, and I learned that in intermediate algebra, and you probably get to use it in trigonometry if you've taken trigonometry. Okay, I assure you, you're going to get to use this again in calculus. Okay, you get to use it again in calculus. I promise. I promise you. Okay, I promise you. So this is one of those mathematical principles. We call it there, it builds a foundation. Now, do we understand this principle? That's the question, right? So let's see what the statement say. Okay, in this statement, you see there's something called if and only if. What does that mean? You guys are in for a treat, because I only saw this phrase when I was taking calculus class in my younger years. And you get to see this before you take calculus class. So you get a head start. You get a head start. So what does this mean? Okay, so I'm going to explain to you what it means. Okay, so if a product of two numbers is 0, if and only if one of them is 0, this one sentence actually, because the if and only if is actually implied, there are two sentences. First sentence. Okay, we're still talking about grammar of mathematics, the statements and so on and so forth, okay? We try to gain some basic understanding. We try to gain some basic understanding. The first sentence that was implied by this is that if a product of two numbers is 0, then one of them is 0. One of them is 0. Okay, the second sentence. The second sentence, it implies, okay, if one of two numbers is 0, their product is 0. Okay, I want you guys to write down these sentences to see if you don't look at mathematical symbols, does that make sense to you? Do you agree with it? Okay, so what it's saying is that the first sentence says if a product of two numbers is 0, say if A times B is 0. Shorthand notation, then, okay, I'm going to use arrow. We use arrow, then A is 0 or B is 0. Do you see there's a difference between this this symbol and this symbol. What's the difference? This is like a two-way street. This is a one-way street, right? Yes? This is a
Yeah.
one-way street. This is a two-way street. But what the second sentence say? The second sentence say if A or B is 0, okay? And another arrow will say, then the product is 0. There's certain logic behind this, because in the first sentence, it says, this is the condition, and that's the conclusion. In the second sentence says, this is the condition, and the other is a conclusion. They're kind of reversal to each other. And when we switch the condition of condition and conclusion, it is still true. You follow me? Does everybody follow me? So to combine these two, we get this double direction arrow, which is two-way street. It's basically saying that if this is true, then that will be true, and vice versa. Vice versa. So if we switch the direction of condition and conclusion, right, it is still true. In your calculus class, you will also encounter if and only if, and you need to know how to learn how to read it. Okay? In some situation, it's only one-way street. In some special situation, you may have two-way street. In other words, if you swap the condition and conclusion, it is still true. Okay, so this is true. And this is true. Right? Because we have both truths, therefore, the one-way street becomes two-way street. And two-way street implies two one-way streets. Do you follow me? Do you guys follow me? This is another piece of grammar in mathematics, which is if and only if. And this piece is what you have learned. Most of you have learned. I believe most of you have learned in your algebra class. Because the second piece is too obvious, right? If you have a 0 in your product, the product is going to be 0. You'll know that from pre-algebra. And this first sentence is more used because when you are solving equations, we often ended up like this. So that's why it's called zero product property. Okay, so with that background explained to you, do you think this principle number 5 is self-evident fact? Is it self-evident truth to you?
Yes.
Do you need me to tell you? Or I believe you already know. Okay, and in this semester, I'm going to show you how these properties is being used. And you're going to see how all of these principles guides us in your mathematical journey. Okay, I just explained it to you. This explains to you why you spend so much time doing factoring. You did, right? I did too. Now, so that's principle number 5. Okay, principle number 5. Any questions? And next, principle number 6. Principle number 6. What does principle number 6 say? That's the last principle. What does principle number 6 say?
Principle number 6, it says If a product or quotient of two numbers is positive, if and only if the two numbers are of the same sign.
Very good. Wonderful. And the next part of the statement?
If a product or quotient of two numbers is negative, if and only if the two numbers are of opposite signs.
Wonderful. Don't you already know that? If we explain this principle in the simple term, you can just tell me, okay, if you multiply a positive number with a negative number, and you're gonna get a negative number, right? Right?
Yeah.
Multiply a positive number with a negative number, you're gonna get a negative number. If you multiply a negative number with another negative number, you're gonna get a positive number. Do you know that? Do you need me to tell you? Please say no. You don't offend me because you know that. You already know that. Thank you. If you don't know this, then you shouldn't be in this class, right? But my job in this semester, I'm going to show you how this principle guided a lot of the things we have learned before. 6 principles are covered. Okay, so what I want you to do is I want you to make that 6 flashcards. Okay, some of you have questions. I just send you a sample of 6 flashcards. The 6 flashcards, 1 principle on 1 page. Okay, so let's make that flashcards, and at the same time, we're gonna, we're gonna use these 6 flashcards, 6 principles a lot. So I want you, throughout the semester, I wish you to be aware of the use of these flashcards, and you will see that you will become so powerful. Okay, I want to give you power because these are the principles that has given me power. Okay, it guided me how to teach. It guided me how to grade your work. You'll be interested in that, right? Every time I take points off your work, there's a reason. I already have that reason ready for you at any moment. Okay, so let me share this flashcard, the sample flashcard. You already received it. You should have received it, okay? 1 principle on 1 card. So this is the first card. You guys see that? Number 2, any number at 0 stay the same. Number 3, if. Okay, number 4. Are you guys making those cards? As you're making those cards, you want to be absolutely convinced that these are truth, because these are the rock we're going to build our buildings. We're going to build our mathematical structures. So these are the rocks we're going to build our mathematics on. That's number 4. Number 5. Number 6. Okay, I have 2 slides for this for these cards, but please put a number 6 together on both sides of your card if you wish, if you run out of space. So you should have 6 cards in that order, because I'll be referring them as number 1, number 2, number 3, number 4, number 5, number 6. And you will see that all the math you have learned is built by these rocks. Did you get it? All right. Wonderful. Wonderful. At this point, I want to do something fun with you. Okay. I also want to see how well you prepare for this class, and maybe I will discover that maybe I can help you even better. So you can see there are more slides in these cards I send it to you, and you can take your time to put those in your cards after class, and we will be addressing those definitions in the future. All right, so let me go back to our Blackboard. Okay, let's go back to our board. Now, all 6 principles are covered. I want to have a little fun with you guys. I want to see how you guys can rationalize. Okay, I want to see how well you guys can do your algebra. Rationalize this guy. Okay, and we are like almost 40 minutes into the lecture. Okay, it's time for us to do something, right? It's time for us to do something. Yesterday, we didn't finish this question. I'm sure it might bother some of you. How do you do this? How do you rationalize this? We know we use principle number 1 and we multiply by 1. Okay, and we got to choose our numerator and denominator. Okay, we got to choose our numerator and denominator. And we know we got to choose the same thing to make that number 1. Right? So can you show me your work? And what answer do you get? Rationalize. This is a basic algebraic skill. And I promise you, you get to use it in your calculus class. Okay, I encourage you to show your work. Okay, so now how do you submit your work? And Farouz is helping us here, our TA. So I will, at certain, excuse me. At a certain point, I'm going to make a breakout sessions. Okay, and I will send you to, you can voluntarily choose to work with Farouz if you wish, or you can stay with me. Okay, we just tried this time with 2 breakout sessions, not yet. Okay, I'm gonna solicit some answers. I want you guys to start working on it. Okay, so please show your work to rationalize. And you make your choices to multiply by 1. Here we of course we use our principle number 1. Right? Anything times 1 stay the same, right? This is one of the basic skills, and you get to use in calculus class. If you don't do this well, you can typically lose 10 points on your first exam in calculus 1. Okay, I'm not even joking. Okay, if your professor give you quizzes, you might lose more points. All right, so it's necessary that we know how to do this correctly. So, are you guys ready? Did you write down the question? Because I'm going to form a breakout room, a breakout session. And if you want to work with Farouz, go for it. If you want to work with me and ask questions staying in the main room, no problem. So let's see, I'm going to set up breakout rooms. Let a participant choose a room. I'm only going to have 1 breakout room because we only have 1 TA. How exactly do we, submit answers. Very good. You can take a picture using your cell phone. You work on your paper pencil. You take a picture and you upload it by upload to Pronto or to chat. Okay, some of you can take whatever shot you get, and you guys are better at technology. But you can submit from chat, from inbox, from Pronto, and from text message. Got it? And I'm creating this one breakout room session, breakout room. And if you like, you can join Farouz. Farouz, do you see anything here?
Yes, Professor. How many minutes do you have time? 5, 10 minutes? Which one?
I actually don't know how to set the time.
You can
Oh, yeah,
probably.
yeah.
Yeah.
How much time do you think?
I mean,
Yeah.
between 5 to 10 minutes is your call, or you know.
Okay,
you
I'm
can-
gonna give you 8 minutes.
Okay.
No, well, 12:10. No, wait. 12:05. Okay, 12:05. So that's about 6-7 minutes. Okay, so we
Alright.
ended at 12:05.
Okay, I will go to. breakout
Okay,
room
someone
number 1.
already submitted some work. Wonderful. Okay, so I'm gonna check your work. Okay, so I'm going to upload the works being submitted to us. Thank you very much. Very good job. Okay. Don't worry about your being correct or not correct. Okay, just go ahead and submit your work. Another submission. Okay, we got 2 submissions. So I'm going to save the work. I'm going to go over it. Wonderful. Well, let's see whose work is this. Thank you guys. Keep it coming. Olamide. And then great. Excellent. Perfect. Okay. What I'm going to do is that I'm so pleased with all these submissions. I'm going to go over one by one. The first one is okay. Keep your work coming, no problem. Okay. I've seen some very good work. I'm going to share the screen with you. Okay, for those of you who stay in the room, in the main room, and you can see that this is the work from let's see, Alex? No. Sorry. Olamide? Is that Olamide? Did I
Oh,
pronounce
yeah.
your name?
Oh, you can just call me.
Olamide?
You can just call me Ola. It's fine.
Ola? I
Yeah.
like that name, but I just don't pronounce it properly, and I apologize.
No, it's fine.
Say it again.
Ola.
Ola?
Yeah.
You make it easy for me. Thank you, Ola. Okay. He did a very good work. Okay, this is great. Okay, so he multiplied by 1, and I will make some minor corrections. Okay, so here you're going to put an equal. I saw the equal sign there, but you just want to make it more visible. Okay, and I want you to make this fraction bar a bit longer, and everything else is perfect. Great work, Ola. Okay, do you guys see that? Wonderful. This is how I grade your work. This is how I grade your work. I probably wear my glasses, right? But this is how I grade your work. I check every step. The first step is correct. He chose multiply by 1. And then in my mind, this person is using mathematical principle number 1. No problem. No problem. He did it right. The second step, he foiled. Okay. And of course, foiled is not the only way to do it. If you do it any other way, that's okay too. Okay. Thank you so much, you guys. Now, so that work is graded.
Excuse me.
Okay.
Why did it end with 1 plus under bracket 2?
Sorry?
Isn't it supposed to be? I don't know how to say this. Like, it's supposed to be the thing on 2 underneath thing minus 1, right?
The square root.
The square
Yeah, square
root.
root of, yes. Isn't it supposed to be like 2 under square root? Or how do you say that?
How do you say what?
Square root. Like,
Square root 2 minus 1.
oh yeah.
1, yeah, 1 over square root 2 minus 1.
Wasn't it supposed to end like that? Why is it plus 1 now?
Oh,
Because I multiply with the conjugate.
right. He multiplied the conjugate. I'm going to explain the steps to you, okay?
Okay.
So what I'm going to do is that I'm going to just have a little change of plan. I'm going to close all rooms. And I think our time is almost up. Hold on. I'm going to give them 1 more minute. Wait, did I click the close the room? I guess I did. Okay. So to finish this work, okay, let's wait for the room. Okay, I will explain the steps, okay? But for those of you who submitted, and let's look at the work by Camden. That's a great work. That's great work. But I'm going to show you some corrections. Okay, forgive me. That's my job. Camden, what you did here is correct. Okay, you guys are still submitting, very good. Okay, I welcome all of it, but I may not have time to get all of them, but right now, could everybody see the work by Camden right here on the screen?
Yes.
Yes.
Yeah.
She did a very good work. Okay, she multiplied by 1. And then this equals to, and please, you're missing the equal sign, and everything is perfect. Everything is perfect. So that is done correctly. That is done correctly. Is everybody back?
Yes.
Farouk,
Professor.
are you back?
Yes. Yes, ma'am.
Perfect. So I was just grading some people's work in this room. And I'm going to cover the how-to. I'm going to cover the how-to, and then we're going to continue the grading, okay? Because some people was asking, why do we do that, right? Why do we do that? Don't worry, I will get to your work, okay? All right. Does everybody see the screen? I'm going to bring up. So let's cover the how-to, right? How-to. When we rationalize this expression, we know the only thing we can do is to multiply by 1, right? A heart over heart is equals to 1. And by doing this, we are complying with principle number 1. What does principle number 1 say? Anything times 1 stay the same, right? Anything times 1 stay the same. So, but we're going to choose this anything. We're going to choose the heart in such a way that it is the conjugate of root 2 minus 1. Because the goal to rationalize the denominator, okay, the goal to rationalize the denominator is to get rid of the radicals in the denominator. So at the end of our work, we don't want to see the radicals in the denominator. We want to make it disappear. But we want to disappear, we cannot just cut it out. We have to make sure all of our transformation, our end results has to give us exactly the same numerical value. Okay, have to give us exactly the same numerical value. Okay, so the final answer here, in numerical value, they have to be exactly the same. How do you know? For example, this will give you a clue as how to check your steps if you're so apt to you're so reliant on calculator. This expression is gonna give you a numerical value. You get an final answer, you're gonna get a numerical value. If these two numbers do not give you the same numerical value, you should know something went wrong in your steps. Most of your professors, including the 4-year schools you're going to transfer to, your professor do not want to see those numerical values. Do you guys follow me? Your other professors, and including myself, we don't want to know those. We don't want to see those numerical values. We want to see the values like this. I assure you, that's the case. But for you, behind the work you turn in on your scratch paper, you can enter those numbers to see if you get the same numerical value. In a lot of cases, you can check your answer that way. Do you guys follow me? All right. So that's why we need to follow principle number 1. You have to keep them equal. You have to keep them equal. So the choice of our answer here is that we're going to choose root 2 plus 1. Can anybody offer some answers why we choose that way? Why we choose root 2 plus 1?
Is it because it's the inverse?
Inverse of what? To what?
Of root 2 minus 1.
Okay. You are close. Root 2 plus 1 and root 2 minus 1. They're not inverse to each other. They are conjugate to each other. Okay, that's another word, conjugates to each other. Root 2 plus 1 and root 2 minus 1 are conjugates to each other. What is a conjugate? Right? So what are conjugates? What are conjugates? You arbitrarily choose a number A and you arbitrarily choose a number B. Okay, you choose any two numbers. If you add them, okay, A plus B are, A and B are any two numbers. Okay, and you do A minus B. These two quantities are called conjugates. They are conjugates. Okay, so in this case, root 2 plus 1, A is root 2, B is 1. A is root 2, B is 1. So A plus B and A minus B are conjugates to each other. Do you guys follow me? Did you guys write down the words conjugates?
Yes.
Okay. So if you formulate two quantities by A plus B or A minus B, A and B are arbitrary numbers, then you get conjugates. What's so special about conjugates? What's so special about conjugates? When we add two conjugates,
They make 0.
do they?
They
No,
make
they won't.
Very good discussion. Very good discussion. If you add two conjugates, what do you get? If you add them.
One of them still remain.
All right, Farouz.
Yes, yes, Professor. I want to say if we multiply, we get the product equal 1. Or I want to correct, sorry about that. When we multiply them, we get the result as a difference of two squares in this case.
Right. I want to discuss the different aspect. Okay.
Sure.
So if you add them, what do you get?
2A.
Yeah.
2A. What if you subtract them?
Subtract.
Yeah. You have two quantities, right? This is your algebra. What if you subtract them? What you get?
2 B's.
That's right. You get 2B. Okay. You get to see this. This is going to be used in the future. Okay. And what if you multiply them? What if you multiply them?
Wait, what's the opposite of square root called?
What is the opposite of square root?
2 something.
Squared? Square?
Squares, yeah. A squares minus B squares.
Wonderful. Could everybody FOIL this?
It's the equation, algebra equation.
It is, you're close, but it is not algebra equation. It's a mathematical truth.
Yeah.
It's a
A
fact.
squared minus B squared.
That's right. So it's A squared minus B squared. Did everybody get that? Okay, how did you get that? You FOIL. You know, you add, you subtract, you FOIL, and we'll get to use this. Okay, write it down. Do it yourself. Do you find them easy? Is this hard?
No.
Tell me. Is this hard?
Mm-mm.
No.
Good. I'm glad to hear. If it's hard for you, you just have to do it. After you do it 5 times, it's easy. Right? Remember I told you how hard I worked? Right? You can do that too. It might just take you twice. You get it. So if you FOIL this, what you get? What do we get? A times A is A squared.
A squared minus AB plus AB minus AB squared.
It sounds so easy to you. I'm so proud of you. And minus AB and plus AB makes what?
0. 1. Wait, 0.
Cancel out.
Yeah.
That's right. Yay. So now the question is, what do you call this? This is not an equation. This is a truth. This is a true statement. This
There's
is a
like
statement.
7 other truths like this, right?
Yes, this is
Yeah.
one of those mathematical
A
truths that will go
squared
to,
plus B squared.
it's going to last to eternity.
Yeah. I don't know what it's called, but I know what it's called in my country.
Very good. Okay, so we're going to figure out a name for it. We're going to figure out a name for it.
Is
So
it
there-
difference of squares?
Sorry?
The difference of squares?
Principal square.
Difference of squares. Perfect.
Difference of 2 squares to be perfect.
Difference of squares. Okay, difference. You guys are wonderful. Difference of squares. Okay, or product of conjugates. Can we say that? One is addressing difference of squares, which is addressing the right-hand side. But if you say product of conjugates, right? These two are conjugate to each other, the product of conjugates. Can we say that? We are building our mathematical vocabulary. Do you know that? If you have forgotten, now it all comes back, right? Well, if this is the first time you learn it, you got it. Are you guys with me?
Yes.
All right. So what's so special about this property? Number one, you get to use this property a lot. Okay. Number two, we got to know how to use it. And but beyond those 2 points, we need to understand this is a mathematical truth. It's not an equation though. It's not an equation because the equation is a conditional statement. Remember? And this is an unconditional truth. Okay, so this is unconditional truth. What does it say? This unconditional truth says, okay, so I'm going to put this over here. I'm going to explain to you what it means. Meaning. This statement says if A is any number, B is any number, You form a conjugate. Is always the same as a squared minus b squared. No matter what number you put in, this is going to be a true statement. And how long this is going to be true? It's going to be true forever. It has been true for the previous 5,000 years. Or 10 million years, I don't know how many years. And it is going to be true for you. It's going to be true for your children. It's going to be true for your grandchildren. It's going to be true. It's going to be true for all those generations after you, after us, for eternity. That's what it means. This is one of those statements that is true. So this is a true statement, okay?
So Professor, I can say, for example, based on what you said, is product of conjugate pairs is equal to difference of two squares.
Perfect. Can you write it down?
Yes.
Can you
Back
put
of
it
my-
on the chat so everybody can write it down?
Oh, I was suggesting we can write it back of our flashcard when we create this one. We back of it, we write it in words, and I help
Great.
them.
Why not? Why not? And this is one of those formulas that we have to understand. It's a mathematical truth. It's mathematical truth. Is it going to be true forever? For example, I'm going to give you an example, okay? I want you guys not to use a calculator for this work. Suppose that if you are the first one to get the answer, you're going to get a cookie. Okay, I'm too cheap. I cannot offer you $1 million. Okay, let's see who's going to get this answer fast. No calculator. Who's going to give me the answer fast? Put your answer on chat.
-98 minus 2 multiplied by 98 plus 2.
So what are you trying to do? That's right. You try to use the conjugate, yes?
Yeah.
And do you need a calculator?
No, 98 and 2.
You got it. What do you end up with? That's
Yeah.
the power of this fact.
Cool.
Do you feel good?
Sure.
You see, this fact tells you that. Right? All right. So now you understand what this is, right? Now you understand what this is. Wonderful. But I cannot give you a cookie. I can give you a symbolic cookie.
Thank you.
Good job. Good job. I know everybody can do this, okay? I just don't have time to get to everyone, okay? So this property is very useful. Now let's go back why we choose this, right? So let's go back to here. When we multiply √2 plus 1 with √2 minus 1, what do we get?
2 minus 1.
Right? So we are in a situation of a plus b multiply a minus b. And we can use that amazing fact, amazing truth in mathematics. So we will turn this into what? Square root of 2 squared minus 1 squared. As a result, square root of 2 squared is going to be 2. 2 minus 1 is going to be 1. You guys follow me?
Yeah.
By doing so, we
That's actually
got-
pretty cool. It's easier.
Thank you. I'm glad you see that insight. Okay. And then we got rid of the radicals in the denominator, didn't we? Because in the denominator, we're going to do multiply denominator with denominator, and the numerator stay the same, right? And then one more steps, right? I also wish to show you how to show your work, right? And over here, you can just insert this piece over here if you want to show some work to your teacher, right? And what will be the final answer?
I get it now. I was like, what?
Good job, you did it. Right?
Oh, okay.
I'm so happy for you, especially I enjoy the laughter, right? Sometimes we were so intense, right? We're doing math. Hey, we can have a little laugh. We can have a little fun, right? Very good job. Very good job. You get it?
Yeah, I got it. Thank you.
I'm going to give you a pat on the back symbolically. But could you do that for me? Yeah.
Are we missing the multiplication symbol in the beginning? 1 over root 2 minus 1 times?
This time, you want to put the times here?
No, above the line
Here?
above. Yes,
It's not necessary.
okay,
You can have it. You don't have to have it.
all right, thanks.
Thank you. Okay, that's a good point. So this dot is optional. You can have it, you don't have to have it. If you have it, it just, just to emphasize this multiplication. If you don't have it, by default, it will be considered as a multiplication as well. Okay? All right. So let me see the other work. Okay, let me see the other work by you guys turning in. Very good work. Okay, so I'm looking at Elijah. Elijah. Am I right? And this work is by Alexa. Alexa's work is very good as well. You just don't forget those equal sign and Norma's work. Norma's work is perfect. Alias work is perfect. Okay. And wait. And this work by Adrian. I'm going to show that work. You don't mind, Adrian, right? Adrian, you mind?
I don't mind.
Okay, thank you. I really appreciate that. Okay, because I want to show people how I would grade this work, and I really appreciate you guys' generosity in this, because it's sometimes I have to feel for you that I'm grading your work, especially in this case. I'm gonna make some corrections to your work. I hope none of you will take it personal. Okay, thank you, Adrian. All right, on this piece of work, how would I grade it? Obviously, he got a different answer. Adrian got a different answer.
Are you sharing the screen?
Oh, I forgot to share the screen. Sorry, thank you. Adrian got a different answer. I wanted you guys to contribute to this process. In this particular situation, if Adrian's answer is right and we are all wrong. Okay, so how do you know if his answer is right or wrong? Did I just tell you a simple way to check it?
Okay.
If you plug in the numbers in your calculator, you're not going to get the same answer. Yes?
Yes.
Are you going to get the same answer?
No.
So this obviously there's something wrong, right? Is there something wrong? Okay. In fact, this step he did, I will not judge it wrong because he did use principle number 1. So and on this step, I'm going to give him 1 point for using principle number 1. And where does the mistake happens? The mistake happens here. Okay, he didn't show much of work, but to me, he seems to tell me, he's telling me he multiplied root 2 minus 1 with root 2 minus 1. What he's telling me is that he's telling me root 2 minus 1 squared. He's telling me, okay, root 2 minus 1 squared is equals to 1. I certainly cannot agree with him. Do you agree with him?
No,
Where is that at?
wouldn't it be?
Angelica is asking question. So what are you addressing, Angelica?
No, just because George was asking where do you submit the work, and I was also asking, and Alexa said to Pronto, and I said, where is that at?
Oh, okay. You know how to do it, right?
She said it's on Canvas, but I don't see it on my page.
You were supposed to download Pronto onto your phone and just take a picture of the problem.
Yeah,
Okay.
you need to download that. Okay. All right. You can do that later. Right now, for now, just look at the screen. Okay. Root 2 minus 1 equals 1. Do you think this is true? You can use your calculator to check this is not going to be true. So what a mistake has been made, I suspect, okay, so this is certainly not true. I suspect the mistake might be the following. Could I bring up my screen? Okay. I'm going to put it here as a common mistake. In this situation, if we recall what we just saw on the screen, root 1 square root of 2 multiply square root of 2, what does that equal to? That's root 2 minus 1 squared, right? This equals to 1 is false. So this is false. This is a false. Max says, okay, I got it. Thanks. Download the Pronto. It's on the App Store. Okay, good. I appreciate you guys. We're helping each other. Okay, very good. The common mistake is that when people see this, they will do that. I suspect that was the mistake Adrian made. Am I right, Adrian?
Yes.
Okay. If you have other work you want to show me, I'll be happy to see it. Okay, because I'm on a mission to correct these kind of mistakes. These mistakes are very common. I saw these mistakes when I was teaching calculus classes. Okay, so it's very, very common. To a lot of students, okay, when they see something being squared in the parentheses, they automatically distribute the power to the term inside, including cases like this. And this is very common. Very common mistakes. You see how intuitive it is to do it. Isn't that very intuitive for you to do that? I can see that. But it's not supported by mathematical truths. It's not supported by order of operation. It's just not supported. Okay, so I'm on a mission to eradicate this kind of mistake. Okay, so this is false. And this is false. Okay, and what is true? What is true? We just did that. This guy is true. Okay, so I'm waiting for you guys to write it down. And I'm going to explain to you a bit more. It's not difficult to know this is false, right? Because if you just plug in numbers in your calculator, you know this is wrong. Okay, we're getting more sharing of the pictures. Thank you so much. I'll try to get to all of them. Do you guys get this? Right, so this is a common mistake. These are a common mistake. Why they're a common mistake? And this will be the counterexample. Remember, we talk about mathematical truth, right? If true is always true, false once, false. This is the false once case. If this is a false once, and this is a false, do you follow me? Do you think this piece of, this part of lecture will eradicate this mistake? So you never ever do this again? Yes or no? Are you convinced? Are you convinced? This is false, right?
Yes.
Okay, so let me continue to look at some other, thank you for sharing, okay? I just want to go, and this work by Marcos, it's perfect. You're just missing some equal sign. Make sure you put the equal sign in places. Forgive me, I'm going to be a little fast. And let's look at this piece of work. Okay, thank you, Chris, for sharing this work. This piece of work, when you multiply, this is good. This step is good, this is wrong. Why? Because root 2 minus 1 times root 2 plus 1, it equals 1, it doesn't equals to 3. Okay, could you tell me how you get 3, Chris?
I accidentally assumed that I completely forgot that I was dealing with a negative on, where I wrote in red for 1 over root 2 minus 1. I completely overlooked the fact that this was a negative, and I assumed it was a, well, no, I didn't just look over the fact that it was negative. I looked over the fact that root 2 and multiplying root 2 by itself was not just 4, it was root 4, which would then go down to 2, and then that would be subtracted by -1, which would equal 1. So that's where I went wrong.
Okay, so you have corrected.
Yeah, I have it corrected.
Okay, thank you for sharing that. So I hope everybody learned the lesson this way, right? So this is the great value. This is the great value of that, of sharing the work. So let me see, this work is by Alejandro. That's perfect work. Vincent's work is is, I have a little hard time. Vincent's work is, do you know what's wrong, Vincent? Your work?
Yeah, I had a
Your
common
work is
mistake.
similar to,
Yeah.
yeah. So I just want to let you know, and this work is by Body Canned. And his work is
Wait, it's a she. It's me.
a she. I'm sorry. Do you know what's wrong now?
Yeah, I do.
Okay, thank you. So
Yeah.
if you have any questions, please don't hesitate to talk to me. And Jose, you know how to correct it now? Jose, are you there? He didn't respond. Jose's work, you didn't do much work. You have to make sure you get it. And Kelly's work is perfect. She basically just a foil. Is that a she or he? Kelly?
It's a she.
Okay, she. Thank you so much.
Thank
But
you.
anyway, and Carlos' work. I have to share Carlos' work with you guys, and you can see if you would let me. Okay, so I'm going to share with you Carlos' work. Do you guys see that? Can you help me grading it? You have made this this piece too long. So the way you write it, it's not going to be root 2 plus 1. It's root 3. Okay? If you turn in this work, Carlos, I'm sorry, I have to tell you the cruel reality. I have to tell you the cruel reality. I think I kind of sense you know what to do, but if you turn in this work, you're going to get 0. You get 1 point because you follow the principle. And the rest, you're not getting any point. Okay? And you also mutated my work, mutated the question. Carlos, I hope you don't take it personally, okay? So you completely changed the question by not writing the radical bar properly.
Yeah, I noticed after the fact, but.
Okay, thank you. I appreciate you share that work generously with us, so our classmates will learn that too. Okay, wonderful. I really, really do appreciate you guys sharing this. Riley's work is perfect. Max's work is perfect. Okay, and Christina's work, let me see. Yeah, it's good, but just don't make that fraction bar too long, okay? And the last one, Angelica. Angelica's work, let me see if I get to view it. Okay, do you guys have any other questions?
No.
George has on chat, Professor.
Oh, thank you. I have a little hard time to upload your picture, Angelica. Could you send it to me again? Let's see the chat question. George is, how do I access Pronto? Oh, you need to download an app called Pronto. It's a green button app. It's on your cell phone. Go to your app store, search for Pronto, and download the one with the green icon. Thank you, Riley. That's very helpful. That's very, very helpful. It won't let me. I'm not sure since I sent it to my computer. Okay, Angelica, maybe you like to come to see, maybe you like to stay after class too. We can get your work checked. But anyway, so let's go back to our picture. Okay, let's go back to our classroom. So this is about rationalizing denominator. You're gonna have some homework. You're gonna have some homework, which is gonna be assigned for you to practice with rationalization. Okay, as you understand, you're gonna have to do this with even a little bit more complicated situations for your calculus class. Is that clear, everybody? So the part I'm assigning you is going to be in the notes. It's called Basic 34A. Basic 34A. Okay, so I'm going to update that piece of work. Share, so chat. Let's see. All right, you guys are helping her. Very good. Okay, so I'm going to show you that I'm going to update your homework. Okay, but this piece of homework is going to be 34A. You guys see that? And you're gonna have a quiz. Okay, basics 34A. I believe it's on page 98. Okay, I could be wrong.
It's on page 96.
Oh, thank you. Page 96. Thank you. Page 96, basic 34A. Okay, so you get to practice rationalization. Rationalization, that's today's homework. Okay, do I collect your homework? I mentioned earlier, no, I don't collect your homework, but I will be quizzing on how well you do on your homework. I will quiz you on the lectures. Okay, is that clear, everybody? Thank you for that prompt.
Will we review our homework the next morning or no?
I'm sorry?
Will we be reviewing the homework?
If you have
After we
any
do?
homework questions, feel free to ask me in class or come to my office hours or ask Farouz.
Yes, ma'am.
Wait, so after we do the homework, will we be reviewing it?
If you have
Correct
questions.
mistakes.
If you have questions.
Oh,
If you don't bring it up, I just assume you guys doing it.
so you won't check if it's right or wrong?
No. I won't check one by one that you from each one of you to check the work. I would need a TA to do that.
Oh, I see.
But I will quiz you on those work. So I will select some questions from homework and quiz on you. You know what I mean?
Yeah, but so how will we know if we're doing it right or wrong?
Well, I will give you the tools to how to self-check.
Oh,
And you
okay,
can
thank
you can also ask me.
Okay.
Okay. The mathematical principles will be how you do the, you know, the tools that we learn in class. Basically tells you how to do self-check. And of course, not all of us will learn how to do self-check immediately, and always feel free to ask me.
Professor, I think I sent it correctly now.
Oh. Thank you. Yeah, I think I got it. Perfect. perfect word. But you don't want the answer end up with a denominator equals to 1. Okay, just remove the denominator.
Yeah, I took a picture, but yeah, Farouz said not to do the one
Yeah,
underneath.
just remove that. Okay. Thank you very much. So we have reached the end of the class, and now I think you guys are getting more used to the rhythm of the class, right?
Yeah.
Very good. I really, really enjoy your participation. And I think your participation is essential for your success. And your success is my success. Okay, because my success is helping you successfully and make a good grade in your Math 190 class. All right?
Professor, I had a question.
Yes.
For our quizzes, are they going to be completed like during our class time, or are we completing quizzes on our own time by the due date?
On your own time.
Oh, okay. Thank you.
Mhm. Any other questions? Otherwise, I'll see you guys tomorrow. And just a quick reminder that I will be out on Thursday for an outpatient surgery. So there will be no class, and out tomorrow night, and I will make time to do the lecture, to record a lecture, and you guys are all welcome to attend. And I will determine the time, let you know. I think it will be around, is in the evening. And I will send out message and I'll send out information to you.
Professor, I want to add something for Thursday, if I'm allowed.
Yeah, of course.
Since you're not going to be lecturing, I may create my study, group for that window of time. So
Sure.
a student can bring their homework question, any questions so far we have learned. So that way, Thursday from 11:15 to 12:50, I will bring my Zoom. I will send it to you guys, my Zoom number, so you can attend. So ask your question.
Oh, that's wonderful. Thank you so much, Farouz, for doing that.
You're welcome, ma'am.
Thank you, Farouz. So just wait for those information to come your way. And I'm glad that Farouz stepped in my place to help you guys with the homework. Thank you so much. Appreciate it.
Thank you, class. Thank you, professor.
Thank you, everybody.
Wonderful class. Thank you very much.
Wonderful, absolutely wonderful.
So, Professor,
Yes.
on the homework, what does it mean in and or patient on the homework?
On the homework, what did I say?
So the step says rationalize the denominator, result in one product and or patient. So I'm just confused on what and or patient means.
Is the wording on the homework?
Yeah.
Okay, let me check. It could be my typo. 34A, result in one product or well, quotient. I'm so sorry. In one product or quotient, not a patient. I'm so sorry. I'm glad I've been using this for a couple of semesters. No one pointed out. Thank you. It's a quotient.
Oh, okay.
Thank you. I really appreciate it. I'm going to change it right away. It's not a patient. Quotient. You guys should have a good laugh about me. Quotient. I changed it. Patient. Oh gosh. Result in one product or quotient. Okay, one product or one quotient. Thank you so much. I really appreciate it. Okay, any other typos you have found? Please let me know as soon as possible.
Is it just 34A?
Just 34A. But if you want to do more, go for it.
Okay.
Yeah, because I do have 34B,
Yeah.
What I would do for it is this. So I will be, if I quiz you guys on 34A, I will only choose questions from 34A. I will not be choosing questions from 34B. But if you feel that you need more exercise, go for it for 34A. So go for 34B. And if you have any questions on them, and I'll be happy to answer them. Make sense?
Yes.
Thank you. All right, I'm getting more messages here. Okay, guys, I will see you guys on. So tomorrow I will announce, Farouz, that you're going to be available at the time of the lecture. That even though I will not be available, there will be a recording, and you're going to help a student with the homework.
Yes,
And I really-
Elijah. Sorry, Professor.
I really appreciate it.
I sent my Zoom ID number for Thursday on chat, and I will repeat and send it again through Pronto.
And
thanks.
Carlos' work is perfect. Gary's work is perfect. Hazel's work is perfect. I got it.
Oh, Professor, so if we ever have a specific question, or like, I mean, a question on a specific problem on the homework, could we just bring it up during the next class?
Absolutely. You
Okay.
can bring it up to the next class. You can send it to me via Pronto during the day, and you can put it. Actually, we can also use a discussion board.
Oh, okay.
So don't let your question stay silent. Okay, let me know. Let Farouz know that we are here to help.
Okay.
Okay? And I mean business, that when I say I'm available anytime you need me, it doesn't mean that I will get to you right away, but I will get it to you. Okay, but you need to let me hear you. Thank you.
Thank you.
Of course.
As you said, Professor, in the discussion board or in Pronto, anybody can answer and help each other. That would be wonderful too. We are just like a team, one for all for one.
That's wonderful. Yes, absolutely. Yes,
All right.
absolutely. Thank you, Farouz, for chiming in, making that comment. I really, I totally agree with you. And this work, Carlos' work is perfect. Just you missing equal sign. So put them there. Christopher. Oh, very good. Very good. Excellent. So I will see you guys tomorrow.
See you tomorrow. Thanks again, Professor. Bye.
Thank you very
Bye.
much.
Thank you.
Bye,
Have a
class.
nice day.
Thank you. You too. Have a great day. Good job. Wonderful job.